Here we are, the end of another week.
Yay.
March 6th, Friday, March 6th, 2020. 404, now that you know what a congruent shape is, they are exactly the same size and shape. So when it came to triangles, we said they were congruent because either all the sides were exactly the same length, or two sides created an angle in between them that were the same length, with the angle being the same degrees, or in between two angles that were the same degrees, you had a shared side that was the same length. We call that side, 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 angle, side, or angle, side, angle. Okay? So we recognize that shapes can be exactly the same, even if, listen to this word, they're oriented differently, right? So I can have a triangle that is, and I'm not drawing it perfectly, of course, but I can have a triangle that's pointing left, and I can have that same exact triangle pointing right. They're still congruent, they're just oriented differently, right? Right? Okay, so we're going to start today learning that now that we know they could be the same, well, what if one, what do you call it when you look in the mirror? What do you see? Reflection. What if one of the shapes is oriented in such a way that it's a reflection of the original shape? So, reflections and symmetry is the lesson for today.
I got the wrong one.
Well, at least you're not leaving today to go see the nurse. Go ahead.
Actually, it's just on this.
But you have this thing about leaving math class. Oh, really, David?
Yeah, and every class. And every class.
Okay, 404. That picture on page 404 showing that same person, obviously, but a reflection. Everybody see that? A reflection is a transformation. What do you call those toys where it's one thing and then you move a few parts around and now it's a what? Transformer, right? You've changed it. So a transformation is when you take a shape and you change its position. You can change its position by simply going like this. Here's the triangle, and it kind of reflects over itself here. So it's the same thing, it's just different. Like when I look in the mirror, it's the same me, but my right hand in the mirror is actually my... You ever played that game? Or do you still get confused when you look at it? Is that really my left hand? No, it's my right. Why does it look like my left hand?
I've never played this game.
No? As much time as you spend looking in the mirror and you've never done something like that.
I tried to see.
Huh?
I say to cry in the mirror. I don't know why.
Okay, hold on. Wait a minute. What?
You talk about the mirror.
So you were practicing your acting skills by watching yourself cry in the mirror?
No, it's fake crying. I was doing different faces, and then I got myself to, I was like, maybe I can be an actor like Jonas does in some plays. And so then I just made myself cry. And my dad thought I actually hurt myself.
Micah.
This is a serious question. On page 404, is that a boy or a girl?
This is a serious answer. That's why I said this person. I didn't want to make that judgment because the one time I look and it looks like a girl, the next time I look, I'm not so sure.
I think it's that's it.
The book was published. Listen, the book was published at a time when we weren't meant to be so confused but so, you know, if the book was published today, you'd be like, maybe they're purposely trying to get us not to see if it's a boy or a girl. but the book was published in a time when that wasn't happening. Because now we live in a world where it seems like it's on purpose. All right. Can you tell that the crescent-shaped blue and the crescent-shaped red are exactly the same thing? And they are reflections of one another. Everybody see that without talking, please. Give me an affirmation like a nod of your head or a thumbs up. Can you see that the red star is not a reflection, or the blue star is not a reflection of the red star?
Yes.
Is it congruent?
Yes.
Yes, but it's not a reflection, because the reflection would be, it literally just kind of is the same except flipped over. Make sense? Can you look down at the bottom of 404 and see that the blue trapezoid and the red trapezoid are congruent and reflections? And in this case, they are reflecting over, listen to these terms, ready? The red trapezoid is a reflection of the blue one, and it reflects over the y-axis. Let me say that again and look at it. The red trapezoid reflects over the y-axis. Raise your hand if you don't understand what I meant. Remember, the horizontal axis is always x. The vertical axis is always y. And you'll notice that they have reflected one trapezoid exactly over the y-axis. Does that make sense? So if you were to look at the points for A, B, C, and D on the blue trapezoid, what are they? -1, 1. What's the corresponding point on the red trapezoid? 1. It's 1, 1. What happened? What was the difference? How did we go from -1, 1 for point A on the blue trapezoid to 1, 1 on the red trapezoid? The corresponding point, point A, and they call that little tick above the A, the little 1, A prime. It's like corresponding with. Why is the point A prime -1, 1? What did they do? We went from 1, 1 to -1, 1. How does that get accomplished mathematically? Zacchaeus.
It's on the other side. So
How does it get accomplished mathematically? You can see it's on the other side, you're right. But how do we do that mathematically? Jaden.
Instead of graphing it to the left, you graph it to the right.
But how does that get accomplished? How do you compute that? You guys are telling me what it looks like.
Number.
What?
Number.
Opposite? What do you mean opposite? Yeah?
It has to reflect on the opposite side.
Right, but how, listen, you're right. But how does it, there's a simple way to make that happen. Mathematically, computationally. And it has to do with opposite. Yeah.
You like, I don't know what it's called, but like the.
You do know what it's called.
The areas of like.
No, quit, no. I'm talking about just point A. Point A prime corresponds to point A. Look at the coordinates for point A. What are they? 1, 1. Okay. What are the coordinates for A prime? How did that get accomplished? What do we do to make it go from 1, 1 to -1, 1? Who said that? Do what? Which one do we multiply by -1? Remember, these are ordered pairs. The X point. It's always X and Y, right? What are we reflecting over? The Y-axis. So all you do when you reflect a shape over the Y-axis is multiply the X point by -1. Does that make sense? See if it makes more sense as we go through. What's the point B? The blue trapezoid. What coordinates of B? Zacchaeus. we're still at the bottom of 404. They're listed there. What are the coordinates of B? Negative 3, 1. What are the coordinates of B prime? Showing that it corresponds with B. What did they do to the X coordinate? Multiply it by negative 1. What did they do to negative 4, 3? When it reflects over the y-axis, you simply multiply the x coordinate by so negative 4 becomes 4. Point D, negative 2 becomes 2. It's a simple rule. If you're going to reflect something over the x-axis, or y-axis, just multiply the x coordinate by negative 1. And keep the y coordinates the same, and you'll be able to plot those points and draw the exact same trapezoid. Let me say it again. They were able to draw the red trapezoid simply by doing this. Put your hand over the right side of that graph. Pretend you're just a blue trapezoid. You would be able to. You would be able to draw that exact same trapezoid on the right side of the y-axis by simply taking the coordinates for the blue one and multiplying all the x's by negative 1, connect those points, and you got the same trapezoid. Does that make sense? It's kind of like yesterday when we just kind of learned the basics of, hey, I can make the same angle with a compass. I could create the same trapezoid, a reflection of it, by just multiplying the x terms by 1. Now, this only works if you're reflecting over the y-axis. Question for future. What do you think you're going to multiply by negative 1 when you reflect over the x-axis? You're going to multiply the y coordinate by negative 1. So what seems complicated, it comes down to a simple rule. You just multiply the first coordinate by negative 1. And you get something that reflects over the y-axis. Make sense? Maybe not totally yet. We'll keep going. What is a reflection? There's a big box there at the top of 405. To reflect a point in the x-axis, multiply its y-coordinate by negative 1. To reflect over the x-axis, you're just going to multiply the y by negative 1. Everybody get that? Yes? Dina? You're hesitant. Go to page 406. How many know what symmetry is? Have you heard that word before?
Yeah. Yeah.
What is symmetry?
No idea. Oh.
But it's the same or reflected on each side.
Okay, so if you can draw a line through any object, and that line creates an image where one is a reflection of the other, that's called a line of symmetry. Any rectangle. Where would I be able to draw a line there that would be a line of symmetry? If I did this, is that a line of symmetry?
Yes.
Yeah.
Would the top and bottom look the same?
Yes.
Did you go to the middle?
Like that?
Yeah. Yeah.
Then the left and right look the same?
Yeah.
What do you got?
Horizontal.
Like that? Top and bottom look the same? Is there one more?
Yeah.
Sydney's like, no, because I drew my line too low. But if I was to draw a line right through the middle here, the top and bottom would be the exact same size, wouldn't they? They would look exactly the same. Through here, the left and right would be the same. Through here, same. One more.
Top left corner, bottom right corner.
Same. Right? Everybody got it? You got it?
Yeah. But your line is long.
I'm not an artist like you.
I know, but like it's not.
It's close enough for these purposes. A figure has line symmetry if half the figure is a mirror image of the other half. A line of symmetry divides the figure into two congruent parts that are mirror images of each other. Look at the seashell. How many lines of symmetry does that odd shape have? That is not a rectangle where we can easily see 4 lines of symmetry. That is a abnormal shape. It's not a triangle, rectangle, it's not a rhombus, it's not a trapezoid. It's a unique shape. So how many lines of symmetry does it have, Zacchaeus? It has just one. Do you see that? If you were to try to draw a horizontal line through the seashell, would the top and bottom look the same? No. But the left and right sure would. How about the starfish? How many points on a starfish? What do you call those? You call those legs?
Yes.
They have arms? Are they called arms or legs? Arms, okay. So if there's 5 arms on a starfish, how many lines of symmetry are there? There's going to be 5. Look at all those lines. Focus on each line and see if it creates mirror images. The one that goes straight up and down, left and right, exactly the same. Everybody see that? Next one. Seahorse. There is no line of symmetry, right?
It's facing towards you, and you cut it in half like this.
It's not going to look the same on left and right because there's only eyes on the right. There's not on the left.
No, if it was facing towards you, because it's facing sideways, there's no lines in symmetry. But if it was facing towards you, then it would.
Do you hear what Zacchaeus is saying? Zacchaeus is saying if you were looking head on, if they had a head-on picture of the seahorse and you went down the middle, then there would be a line of symmetry. Noel's like, we don't know that for sure because we can't see
We
that
don't
picture.
know.
We can assume, Zacchaeus, we can assume, but not that picture, right? Not the side view of a seahorse. Can't do it. Yet to be determined if you could do it front view, right? Anybody have graph paper? Okay, 1 through, because I didn't write that on the, does anybody check RenWeb? I don't think I wrote graph paper on the, I did have compasses and protractors.
Graph paper on there.
Okay, 1 through 14, but I'll be up here doing them with you. Yeah, 1 through 14.
I hate graph paper. Because I got the point. So I have the chart over here.
I think it's more grass than graph. I don't want my binder anymore. I'm not going to do it.
I use it in every class.
And since you left on the ground.
Graph paper till number 9.
Yeah. So you know.
Wait, what are we? 1 through what? 14?
When you get to number 9, what's the simple rule to reflect something over the x-axis. The y-axis, we multiplied the x-coordinate by -1. If we want to reflect this over the x-axis, we multiply the y-coordinate by -1. So all the x-coordinates stay the same. The x's are still going to be 2, but now it's going to be -7. It's going to be -3. It's going to be 6, -4. And 6, -9. Am I awful drawing?
I thought we were. You don't have to look at like, do you have to?
Yeah. K, L, M, N.
No, like this, like, the line, that's like the 1, 2, 3. Like, don't you have to?
Well, dear, this isn't graph paper. I'm kind of doing it.
What do you have now? Do you have it?
Yeah.
I do. I need like. No, okay. I didn't even remember just for.
I mean, I don't have graph paper on. Oh.
Anybody else do graph paper? Graph paper? Yes, it's graph paper. Yeah, it's graph paper. It's graph. Yes. Graph paper. Graph paper needs to be cleaned well. Oh no.
Zacchaeus said it's not nice to say.
Number 9. Yeah.
So the number reflection is multiply all the numbers by negative?
No. If you're reflecting in number 9, they want you to reflect over the x-axis, right?
Yeah.
So you only multiply y-coordinate by -1. So this 2, 7 became a 2, -7. 2, 7 became a 2, -7. 3, 3 became a 3, -3. 6, 4 became a 6, -4. 6, 9 became a 6, -9. And you should see that this is a reflection over the x-axis. And for 10, you're going to go over the y-axis. So then you're going to take that shape that you created in the first, with the first 4 coordinates, and you're going to multiply the first coordinate by -1. Yeah.
So, number 10, yeah, number 10. Is it gonna be on the,
I'll do my rough
Can I do it on the
sketch.
same grade? Can I do it on the same graph?
Can you do it on the same piece of paper? Because I made this one big.
No, because it takes up a lot of space in my fingers, so could I do it, like, is it able to do it on the other side? Are you able to do it on the other side of the, no, because you use that side, so you use that.
Sure, go ahead. But the only thing is, your figure on the left, because you're seeing that the x coordinates are all negative, but remember, you're gonna reflect it over the y-axis. So it's gonna go from here to here.
Okay.
So they're gonna interfere with each other. You wanna do it in a different color?
Oh, yeah.
Or if you don't want, if you need graph paper, I can give you some.
Well, I have graphic, right? I have it all.
Well, that's what I'm saying. If you need it, I'll give it to you. So the rough sketch of 10, negative 8, 8.
So what number is it? What number is it?
And we're going to reflect it over the y-axis now, so we're only going to multiply the x-coordinate by negative 1. So instead of negative 8, 8, it's 8, 8. Instead of negative 4, 7, it's 4, 7. That's the rough sketch. By the way, I always have dry hands, so I just licked my finger to get the paper. And I was with a lady yesterday on the news, like an official CDC giving a message on it, right? And she was talking about all these things we got to do, like, you know, of course, not put your fingers in your mouth, or not even touch your face, right? So she's up there reading. The whole world's watching. And she's giving all these instructions on what not to do. And she went to turn the page on her little thing she was reading, and what'd she do? She licked her finger and turned the page in the midst of telling everybody not to do it. I mean, it's just funny. It's a it's such a habit, but it was in the middle of telling everybody not to do that.
I know. My purple pen.
Yeah, thanks for your honesty. No, we just don't want to do it.
I hate this. I made my squares, the graphs, 12 by 12. So. What? I made them 12 by 12, so they're way too small. Let's see how big the numbers were. I made the graphs before I looked at the numbers.
People don't plan to fail, they fail to plan. Catch that? People don't plan to fail, they just fail to plan. So he was like creating his graph, but he didn't stop a second and plan it out, like how high is it gonna be, how wide's it gonna be.
I did the line. This is well, so look, you watch this. I'm being Isaac, watch this. It's be on how
Only for the dad.
Oh, walk out. Yeah, I'm watching.
I'll
Yes, and now very
Look at that. Look at how beautiful that is. Okay, let's try it. And it's right. That's two of them. There's off.
His hair in the wind. It goes from here all the way down.
I did that. Yeah. Yeah, I'm way taller.
Oh, you did? I'm just gonna keep my eye.
Actually, they're
Mr. Franklin. I'm confused on number 12. Okay. Because it has 0 in it, and you can't have a negative 6, so then you're just staying in the same spot.
Number 12. So, Zacchaeus, that has nothing to do with math. 12, your fourth point is -6, 0, right?
Yeah.
So, you're going out here -6, and your y point is 0, so you're right on the x-axis, and you're reflecting over the x-axis. You with me?
Yeah.
If you're reflecting over the x-axis, you are multiplying
0.
the 0 by -1 is still going to be
It's just
0.
It's not yours. Stealing my thing. It's not yours.
Is it?
Yes, it is. Last year we used.
So give us a,
She said we could share it. Give it back.
did she say we could share it?
No. and she told me to keep it and put it in my spreadsheet for them using it.
David, you're done with 14.
No. I'm not done.
Okay, so all of this, and you're not even done.
Wow.
You're not done.
Yikes.
I think I did it right.
Does your number 10 look something like that?
Yeah, that's what it looks like.
And number 9 looks something like that?
Yeah. Somewhat. Somewhat.
Yeah. 14. We're going over the y-axis. So you multiply all the first terms by -1. So of course, they're going to share, yep, right on the origin. Looks pretty good.
It's really quite nasty, that kid. Quite an appetite.
Okay, did you get for number 3? Did you get that the red figure is not a reflection? How many put that it was a reflection? It's not. It would be a reflection if the red one was upside down, but that's a transformation. It's the same figure. It's congruent for number 3. Number 3, the red and blue are congruent, but they're not reflections. The red one has been moved. It's been transformed. What we're going to learn Monday, it's been translated. It's been moved to another place. Number 4, is it a reflection?
Yes.
Yes. Number 5, reflection.
No.
No. Close. Could fool you at first.
Gotta look at his eye.
Oh,
Yeah.
Number 6, how many lines of symmetry? 1. There's only one place that you can draw a line through that figure number 6 and have it look the same on both sides, top and bottom actually. See that, David? Number 7, how many lines of symmetry? There are none. There's nowhere you can draw a line through that and have it look exactly the same. How about 8? 2. Right through the middle. No. No.
Yes, from this other.
No.
He said no.
Hey, have a good weekend. Sunday, close to 60.
Oh, I have one more.
Sunday, close to 60 with sunshine.
Monday at 6.
Good day to outside. Maybe even hit outside. Good day to throw out.
I don't think that's really. I actually knew baseball the other day. Good job, Rachel. What?
Well, her dad's a big baseball guy.
Yeah.
Well, no, I'm absolutely not.
I tried to tell him. Tried.
What are you doing? Playing with